Okay, we have one more section that's really about the exponent rules. They're going to call it dividing these monomials, but it's why we were learning these exponent rules in the first place. So it gets a little crazy here again, just like in the last video, but let's get started. So if we have the division, so these are two monomials, if we're dividing them, another way to think of division is just as a fraction bar. And if we turn it into a fraction bar, it simply becomes the rules that we've been working on. Now, you can always do the numbers just like they were normally. You could reduce those. So if you had 56 over 8, you could reduce that down to just 7. Now, x to the 7th over x to the 3rd, we know how to handle that. We would subtract those. That was our shortcut, or you can see it's just going to leave 4 up at the top. And there we go. So, division of these monomials is just the same thing as putting it over the fraction bar, which we were already doing. Now, if I had 42 over 6, I could just reduce that, divide both of them by 6, so that's going to be a 7. And I've got y to the 9th over y to the 3rd. So I'm going to jump ahead here. 9 minus 3, there's going to be 6 left up on the top. Okay, same thing here. Okay, so if I were dealing with this, I could divide these down. So if I divided them both by 8, I'm going to be left with 6. Now I have 8 z's on the top, 2 on the bottom. I could subtract those. 8 minus 2, I would have 6 of them left on the top. All right, now things are getting more complicated, but we know all the individual rules. So let's see if I can, yeah, they've done this well. So they've broken this all into pieces where I'm just grouping the things that I can simplify. So 45 divided by negative 5 just becomes negative 9. A to the 2nd over a, you could subtract it, or you see there's going to be 1a left on the top. And b to the 3rd over b to the 5th, you see there'll be 2 b's on the bottom. So you could have done it like this. Get b to the negative 2nd, but we know that's 1 over b to the 2nd. So they just put all that together, and there's what we got. So remember, these rules about simplifying are only true if the bases are the same. You can only put the a's together and the b's together. Okay, so if I did the numbers here first, so if I had negative 72 over 8, this is just negative 9. Now if I had a to the 7th minus the 12, so I have more on the bottom, I'm going to have a to the negative 5th. So I'm going to put those, there must be 5 a's on the bottom, which you can see visually. And then lastly I have b to the 3rd minus the 4 on the bottom. I'd have b to the negative 1, which means there should be a b down at the bottom. And if you could see it visually as well and see. And this is what I'd be left with. So negative 63 over 7. I'm going to just do that fraction. I could divide both by 7, and that's going to be negative 9. Now, c to the 8th minus 12. It'd be c to the negative 4th, or you can just see that it should have been down at the bottom. d to the 3rd over d to the 2nd, there'd be 1d left on the top, and I'd have this. I guess, yeah, I don't really see what's different about this other than they left a fraction in the front. So let's go through this with them. They're working on the numbers, and that reduces down to a half. They're doing the a's. It's going to get me 4 on the top. They're doing the b's. It's going to get me 1 on the bottom. And you get this. Okay, so if I had 16 over 24, I've got 8 going into these, so this can reduce to 2/3. If you need the factor trick, like you don't see that, go back to those early videos. I did that there. But this will reduce down to 2/3. Now let's deal with the letters. I've got a to the 7th, and I'm taking away 1, so I'm going to do this like this. I'm going to have 6 a's left on the top. Now, can you see there's going to be 2 b's left on the bottom if you just thought about it visually? But if you did the rule, you'd have b to the 6th minus 8 is b to the negative 2nd. So let's move that below, And I get it down there. So if we're doing 27 over negative 45, now you could break that down into all the factors, but they're both divisible by 9. So you're going to get negative 3 over 9. So let's just extend that, and now we'll work with these. I've got 4 p's on the top, 12 on the bottom. You see if you subtracted that, you'd have 8 left on the bottom. Q to the 7 over q. If you subtracted that, you have 6 q's left on top. Okay, yeah, I don't really see much different about this. Yeah, I don't really know what they're doing. So 14 and 12, we could divide both of them by 7. Gets me the 2/3. If we looked at our x's, you see we'd have 4 left on the bottom. The y's would have 6 left on the top. So I guess this was just more complicated. I didn't really notice, but so 28 over 49. Those are both divisible by 7. So I would have 4 over 7. Now, I like to just look at them and see that I'd have 4 x's left on the bottom. But if you wanted to think of it like the shortcut, you'd have x to the -4th, which means you got to put them back on the bottom. And if I look at this, I see if I subtracted those, I've got 2 y's left on the top. I just kind of look at it and see, okay, there must be 2 left there. Okay. So if I'm dealing with 30 over 48, those are both divisible by 6. So I'd have 5 over 8. Now let's deal with the letters. 5 of them's on the top, there's going to be 5 left on the bottom. And then look here, if I would have 3 n's left on the bottom as well. Now you can do all the rules and the negatives if you want to. I'm just kind of noticing that's how many would be left, and it's the same thing. Alright, so we've got, before we can do what we just did, we've got some cleanup we got to tackle first. So I'm going to just multiply these guys together. So the 6 and 5 will multiply. We're going to have x to the 2nd times x to the 3rd. We'd add those exponents. We'll add the exponents for the y, which I'm sure they've done for us here. Yeah, so first of all, they cleaned up the top, and we get this. Oh wow, they just went ahead and did it all. Okay, the 3 and 30 would reduce down to 10. X to the 4th and x to the 5th, there'd be 1x left on the top. And then look what happens here. Y to the 5th and y to the 5th, you could think of them as just canceling. Or if you were thinking of it like the rule, that gets me y to the 0. Well, y to the 0 is 1, so that's really going to have nothing to do with it. So all of that simplifies down to 10 to the 10x. Okay, so I'll take you through one of these, but you can always try it yourself. I got to tidy up this top first. 6 times 4 is 24. I get a to the 6th when I put those a's together. I'm just adding them. And b to the 10th. Alright, now I'm going to just reduce both 24 and 12 are divisible by 12, so I'm going to get 2 there. So I'll have an a left on the top, and I'll have 2 b's left on the top, and that's simplified. Okay, totally recommend you pause the video, try this, but I'm going to go through it here. So I'm going to multiply. There's actually something clever. Yeah, I won't show you that yet. I'll talk about it at the end. So you can multiply these guys. I'm going to get positive 48. Going to do the numbers. 6x's and 5x's make 11x's. 9y's and 8y's make 17y's. Okay, so now I get this. Now let's deal with the numbers. 48 divided by -12, or we could think that's -4, or you could think they're both divisible by 4. Same thing. Are both divisible by 12. Okay, you got 11 x's on the top, 10 on the bottom. That leaves 1 on the top. 17 on the top, 12 on the bottom. Subtract that, you're left with 5 on the top. So what I was going to say earlier is this is factored. These are factors here, and so actually the -12 and the -12 could cancel. because this is all a list of multiplication, so that's all factors. So those could have canceled and we could have seen right away that, but we wouldn't have had to do that. All right, I was actually expecting some more there, but so it's gotten pretty complicated, but I feel like it's not too much. Just remember, we've seen all the individual pieces, we've just put them all together. So hopefully you're understanding.